Hello everyone, I am Mr. Kiran Wakchaure from Sanjivani College of Engineering, Kopargaon. This video is the part of project assignment of the course Machine Learning using Python conducted by Skyfi Labs. In this course, we learn the basics of machine learning, and at the end, we learn how to use that machine learning for the project, and that project we have completed using the Python. The machine learning is the subset of artificial intelligence. That artificial intelligence, which is the cutting edge technology and which is the current trend, which change the entire technologies in the world. That machine learning, as we know, in the conventional in the humans, that humans learns from the experience. And if we see the computer, which is the one of the machine which takes the instructions in the form of programs, that means which takes the input in the form of program and gives the output. But in case of machine learning, which which learns from the data, identify the pattern between the data, and make the decision with minimum human intervention. This is the machine learning. In the machine learning, there are three basic types. One is the supervised learning, second one is the unsupervised learning, and third one is the reinforced learning. Again, there are the number of tools which are used to implement this machine learning for the projects to perform different tasks or to perform the different tasks. That programmings are Python, Anaconda, Jupyter. Again, there are some different libraries like Panda, Matplot, again TensorFlow. This is again one programming language. With the help of these tools, we can do the machine learning. Again, machine learning is the part of data analysis. After doing that data analysis, and then that data is given to the machine for the artificial intelligence. Okay. In this project, we learn how to use or how to install Anaconda and how to use that Anaconda navigator. Again, that Anaconda is a Python prepackaged distribution of Python which contains a number of Python modules. You will find the number of Python modules, Spider, then Jupyter Lab, Notebook, which are used for the data analysis and which are the part of machine learning. Next, we have selected this Jupyter Notebook. If you read over here, which is used for the data analysis. I'll just launch this, which is the already installed in the Anaconda navigator, and this is the web based. And if you will find this Jupyter navigator, and next you have to click over here Python 3. Using this, you can start working with Jupyter Notebook. Okay. Now after this, Jupyter is the open source web application that allows to create and share documents which contains live codes, equation, visualization, narrative text. That Jupyter Notebook has the capability to do the numerical simulation, statistical modeling, data visualization, machine learning, and the much more. With the basics of the machine learning, this course covers the project on the machine learning, in which we have to predict the prices of the house of the Boston city, in which they have given the data set which consists of 506 data points and the 13 features. At 13 features, that means which these are the variables which affects the price of the houses, and that price or the cost of that houses, which is the target. Input is the features, which are in this case there are the 13 features, and output is the price, which is that the target. Again, in this case, to start this project, first of all you have to import some libraries. First one is the NumPy, which is used to handle the multi-dimensional arrays. Next one is the pandas, which is used to load the data into the DataFrame objects. Next, matplot library, which is used for the visualization. Next, animation, which is used to animate the data or the animation in the visualization. Next, we have to import the database. For that, you have to use this command Boston. Again, in this we have to import that sklearn library, which consists of many ML algorithms, which gives the better understanding and for the solving of the machine learning problems. Now, in the first step or in the machine learning, we have to import the data. Next, we have to reprocess that data. Next, we have to do the training. Next, we have to do the evaluation, and next we have to do the validation. In the same sequence, we have to do the programming. First of all, we have to import the data. In this case, that Boston data sets, which is having the 506 data, that we have to import, which consists of 13 features and that target price. Okay, now using this, we have to import that data. If we look over here, these are the attributes. That means what is the per capita crime rate by the town. These are the 13 attributes. Next, ZN, these are the variables, which are the labels. Proportion of residential land zone, NOx, nitric oxide concentration. These are the different parameters which affects the price of the houses in the Boston city. And using this parameter, as you move around the city, as you at different locations, this parameter gets changed, and according to that, price of that houses in that city gets changed. This is the problem statement. Using this, that means if you move any instance, any location, using this machine learning, we have to predict the price of that house. Okay. Next one is the features. You will find that feature. Next, we have to store the features from the data sets into the pandas data frame. You will find pandas data frame for the features. Okay. Next, we have to store the target column into the another data frame, which is called as the target. That means this 506, which are the inputs, and this is again 500. This is the one target. This is the price. This is the price column, and again we have the 506 data in that prices. That means for this 506, these different variables, we know the price, and using this, as we change any value in this, we can predict the price of the any house in that Boston city. Here we can find out the maximum target and the minimum target price from this 506 dataset. These are the functions to find out the minimum and maximum. Next one is the DF, which is the data frame. Here we have to connect that features and the target into the single multi-dimensional array. For that we have to use this feature, we have to use this command. Okay. Here we will find earlier these are the only inputs, and in the second phase these are the only output. Now here we have attached that input and output in the single array. Okay. Next, the data frame describe. This function provides a statistical description of the dataset. Now we have successfully completed the visualization of the Boston data house. Here we will find this. Here we have describe it into the two decimal places. Okay, and sorry, and if you move downward, okay, you will find the mean, standard deviation, minimum value 25%, 50%, 75%, total number of counts. All these values will get or description of our total data set you will find using this DF data frame describe. Now next part, now we have to describe the correlation between the target and the attributes. In order to perform the linear regression, we want to know which features can be used to best predict the target value of variable. We done that using the correlation technique. This is the total command line for the correlation technique. Okay. That plot shows the to generate the bar plot. LSTAT has the highest absolute correlation with the target. Now next phase is to do the normalization. Now for the training purpose we are going to do the normalization. We are just going to convert all these values ranging between 0 to 1. Now this is the function for the normalization. Earlier, before normalization, these values are like this in their original form, and after normalization you will find these values are like this, which is in between 0 to 1. Okay. Next we have to split the data into the fixed set as testing and the training data sets. Yes, this is very important step. In the machine learning, the total data set we have to do the for the training, some data set is for the testing, and some database is for the validation purpose. Okay. Here this is the code for the to assign the data set. Again, in this case, to define the error, this function, that error function which returns to the mean square error in predicted values for the given m and c. That means y is equal to mx plus c, that m is the multiplier and c is the constant. To update, here you'll find, to update that value we have to use this function, and that gradient descent is again one new function. With the help of this we can change the masses, change the weights, that m which is the weight, that weights we can change using this function gradient descent, which is the algorithm which is used in this training purpose or the learning purpose. After defining the error, weight update and the gradient descent, which is the algorithm for the weights, next task is to do the visualization using this subplot command, plot command. We'll find this is the data visualization between the, here we have normalized between the limit 0 to 1, 0 to 1, and this is the next regression line. We have plotted line, the which is the error value having function y is equal to mx plus c. It is the difference between the base fitted line and that difference between the predicted and the actual values that we have plotted using this plot, that x-axis is the iteration and y-axis is the error. Okay. After plotting this error, next we have to predict. In this case, we have predicted this mean square error using this function y-test, which is the testing data, and this is the predicted. This is the predicted y is equal to m into x test plus c. Okay, this is the mean square error, which is of 0.23. Okay, next we have to predict the prices. We have to generate the list of predicted values using the line equation. Okay, using this predicted is equal to y is equal to mx plus c. Then we have compared mean square error, and we can see the predicted values. Which are the predicted values? See, this value should be actual values of 0.38, and that value predicted by using this function, which is of 0.39, 0.64, 0.59, 0.34, 0.29. This is the target price and this is the predicted by using this function. Next, we can see the predicted value are approximately or nearly equal to the target values. Next, we have plot the predicted values against the target value by using the scatter plot function. By using the scatter plot function, we have just predicted the actual values and the predicted values. Next, in the last step, which is the validation phase, in this validation phase, if I provide these values and by using this I can predict this value. If we see over here, this is of 22.3, which is the target values, and this is the predicted by the function, which is of 22.76. Using this, we can predict the values of Boston houses if we move in any region according to their crime rate, that nitrogen oxide. These are the different, that using these 13 different features we can predict the values of. I pays my sincere thanks to Skyfi Lab for providing such a great content and with hands-on practice on the machine learning. Thank you very much for your kind support.